E-Chemistry class, Fatima Convent High School, Chapter 2, Acid, Bases and Salts, Class 10th, myself Dipali. Let us move to the next topic of this chapter. Now let us see what is common for all acids and bases. Now in section 2.1, we have seen that all acids have similar chemical properties, which leads to the similarity of in the property. We saw in activity 2.3 that all acids generate hydrogen gas on reacting with metals, and so hydrogen seems to be common to all acids. Let us perform an activity to investigate whether all compounds containing hydrogen are acidic or not. So, take a solution of glucose, alcohol, hydrochloric acid, sulfuric acid, etc. Fix two nails on the cork and place the cork in a 100 ml beaker. Connect the nail to the two terminals of 6 volts battery through the bulb and switch on as in the figure. Now pour dilute HCl in the beaker and switch on the current. Repeat with dilute sulfuric acid. What do you observe? We observe that glowing of bulb indicates that the electric current is passing through the solution. Repeat the experiment separately with glucose and alcohol. What do you observe? We observe that there is no passage of the bulb. The bulb does not glow for both the solution, which indicates that electric current is not flowing through both the solution. This experiment shows that ethanol and glucose do not ionize and do not release H plus ions, while the solutions of acid, H plus ions are released and allows an electric current to flow through the solution. Thus, even though alcohol and glucose contains hydrogen but are not categorized as acid, so we can define acids as the substances which has the capacity to release H plus ions are acids, whereas those which cannot release H plus ions are non-acids. Now, in some cases, they may release OH minus ions also. So if they release OH minus ions, then they are bases. So H plus ion in an aqueous solution are responsible for acidic characters, and OH minus characters ion in an aqueous solution are responsible for basic characters. So the ions responsible for acidic characters are acidic characters are H plus and basic character are OH minus. So if any substance can dissociate into H plus or OH minus, when electric current is passed through it, then it is either acid or basic. And if it does not dissociate, then it is not acid nor base. So, the bulb will start glowing in the case of acid, but you will observe that glucose and alcohol solution do not conduct electricity. Glowing of the bulb indicate that there is flow of electric current through the solution. The electric current is carried through the acidic solution by ions. Acid contains H plus ions as cations and anions such as Cl minus in HCl, HNO3 in HNO3, NO3 minus is present in HNO3, SO4 minus 2 in H2SO4, CH3COOH minus in CH3COOH. Since the cation present in the acid is H+, this suggests that acid produces hydrogen ions, that is H plus aqueous, in the solution, which are responsible for their acidic properties. Repeat the same activity using alkalis such as sodium hydroxide, calcium hydroxide. What do you conclude from the result? They will be releasing OH minus, which shows that the basic nature is due to the OH minus ions and acidic nature is due to H plus ions. Now, what happens to an acid or a base in a water solution? Now, let us test this with the help of an activity. It is to test that dry HCl gas is not acidic, but in aqueous solution it is acidic. Take about 1 gram solid NaCl in a clean and dry test tube and set up the apparatus as shown in the figure. Add some concentrated sulfuric acid to the test tube. What do you observe? Is there a gas coming out of the delivery tube? The gas evolved successively with dry and wet litmus paper. In this case, does the litmus paper change the color? On the basis of the above activity, what do you infer about the acidic characters of dry HCl gas in HCl solution? If the climate is very humid, you will have to pass the gas through a guard tube, drying tube containing calcium chloride to dry the gas. This experiment suggests that hydrogen ion in HCl are produced in the presence of water. The separation of H plus ion from HCl molecule cannot occur in absence of water. Hydrogen ion cannot exist alone, but they exist only in combined state with water molecule. The hydrogen ion must also be shown as the aqueous solution or hydronium ion H3O plus. That is H plus H2O gives H3O plus. We have seen that acids get H3O plus or H plus aqueous in water. Let us see what happens to a base in water. So, we can conclude from this that the H plus ion from the HCl molecule cannot be separated in absence of water, and hydrogen ion are also present, represented by H plus and OH3 minus. OH minus ion is showing the basic characters. Now you can see that bases generate OH minus ion in water, and base will be soluble and are called as alkalis. So if the bases are soluble in water, they are called as alkalis. Now all bases are not soluble in water. An alkali is the base that dissolves in water, and they are soapy to touch, bitter and corrosive. Never taste or touch them, as they may cause harm. Which of the bases in table 2.1 are alkali? So NaOH and KOH are alkali. Now, as we have identified that all acids generate H plus aqueous ion and all bases generate OH minus aqueous ion, we can view the neutralization reaction as follows. So acid plus base gives salt plus water. Now if we take HX as the general formula for an acid and MOH as the general formula for a base, and if I react them, I will obviously get Mx plus HOH, that is H plus aqueous plus OH minus gives H2O, which is water molecule, and plus the salt. Now take 10 ml of water in a beaker, add few drops of concentrated H2SO4 and swirl the beaker slowly. Touch the base of the beaker. Is there any change in the temperature? Is this an exothermic or endothermic process? Repeat the above activity with sodium hydroxide pellets and record your observation. The process of dissolving acid or a base in water is exothermic in nature, and the concentration of the solution by adding water to an acid or a base always decreases. So you can easily observe that the process of dissolving an acid or base in water is highly exothermic. Care must be taken while mixing concentrated nitric acid and sulfuric acid in water. Acid must always be added slowly to water with constant stirring. If water is added to concentrated acid, the heat generated may cause a mixture to splash out and cause burns. So we can never add water to acid. We have to always add acid to water. Very important precautions to be taken. The glass container may also break due to excessive local heat. Look out for the warning sign on the can of concentrated sulfuric acid and on the bottle of sodium hydroxide. Mixing an acid or a base with water results in decrease in the concentration of ion H3O plus and OH minus per unit volume. Such a process is called dilution, and the acid or a base is said to be diluted. So, when we decrease the concentration by addition of water, then it causes the dilution of acid, and the concentration of H plus and OH minus gradually decreases, making it a milder acid. So, when we take concentrated HNO3 or H2SO4 is always added slowly to water with constant stirring, which results in decrease in concentration of HNO3 and H2SO4, and solution gets diluted. Now, why an acid should be added to always water to dilute it? When water is added to concentrated acid or dilution, the heat generated may cause a mixture to splash out and may cause burns. The glass container may also break due to excessive heat. Therefore, for dilution of concentrated acid, instead of adding water to the acid, acid is added slowly to the water with constant stirring. Hence, liberated heat energy during dilution will spread in water and does not cause harm. So, this is the care which has to be taken while we handle concentrated acids. Now you will be able to answer the in-text question. In next session, we are going to check how strong are acids and basic solutions, and we are going to understand what is pH. Thank you.